Hello everyone, this is the fifth lecture on ICR. We'll cover one problem of exercise which is on page number 297. This is the first problem, and this problem is based on central oblique impact. In last lecture we had discussed about the procedure to solve a central oblique impact. In this lecture we'll discuss one problem on it. This is unsolved problem from the exercise. Now in this problem what they have given the magnitude and direction of two identical smooth balls before central oblique impact are as shown in figure. Assuming E is equal to 0.9, the coefficient of restitution is given, and if you see they have used a smooth word here. Determine magnitude and direction of the velocity of each ball after impact. Now what they have given here, this diagram is also given. If you see in this diagram, two balls, okay, they are coming in this direction. This is the figure showing the balls during impact, and if you see the initial velocities of the ball are given as 9 meter per second and 12 meter per second, and they are approaching with the angle 30 and 60. This is also given. Now if you see the direction or velocities of these two balls, they are not parallel or they are not along this line of impact. So this is what, this is oblique impact problem. This is oblique impact. Okay, this is a central impact but oblique one. Okay, as the velocities are not along the line of impact. So we had discussed already how to the procedure to solve this problem. These are the given thing, and now we'll see how to proceed to this problem. So given things are initial velocity of ball A, ball B, then their directions are given alpha, beta, and the coefficient of restitution between these two balls are given. And what we need to find out, the final velocities and the respective direction of the velocities. Now if you draw a velocity diagram or velocity after impact, uh, first what we need to do, resolve the initial and the final velocities. Now we'll consider this direction as our n direction, and this direction as our t direction. Okay, now as we know that the velocity change which are going to take place is only along this n direction. There will be no velocity change in t direction, as we had discussed already, as they have given this balls are smooth, so no friction are going to occur, and there will be no velocity in t direction. Only n direction velocities will going to change. Now just resolve this initial and final velocities. If you see, I have shown here velocities, and we'll discuss about it. These are the initial velocities, okay, with the direction. This angle is given 30 degrees, so this angle will also be 30 degree alternate angle, so I will write here 30 degree. Similarly, this is given 60 degrees, so this will also become 60 degree. Okay, so these are the initial velocity which are given, these angles are also given. Now just resolve this velocity with this va velocity. Horizontal component of it will be van, that is a velocity in n direction of ball A, and vertical vat, velocity of ball A in t direction. Similarly here vbn and vbt. Now we have resolved the horizontal and vertical initial velocities in horizontal and vertical direction. Now let's consider after collision. Okay, the balls are moving in this direction, okay, which is away from each other. Generally the balls moves away from each other, but it is not compulsory that the ball should move away from each other. This ball, okay, may move in the same direction just with the little deflection like this, if it has more mass and more velocity. Okay, depends on the mass of the ball, then velocity with which it is approaching, then angle, the direction after collision can be decided. Here we don't know in which direction these balls are going to travel after impact, so we have to assume a particular direction, and after we get a sign, after the sign of these final velocities will decide whether the direction we have assumed are correct or not. If we get a positive sign, then whatever directions we are assumed they are correct, we can predict that. So initially you assume they are traveling after impact, they are traveling in this direction. So let's say this is the final velocity of ball A, so VA dash, final velocity of ball B, VB dash. Okay, now just resolve these final velocities as well in horizontal and vertical component. Horizontal, that is n direction component, will be VA n dash, and vertical VA t dash. And similarly here VB t dash vertical, and VB t VB n dash horizontal. So this is how we'll resolve the velocities after and before impact. Now we know that the what we need to find out, we need to find out this and this with the angles alpha dash and beta dash. These four things we need to find out. As we know that this is actually a resultant velocity of these two, we have resolved it, so this is a resultant velocity and these are the resolution. So I can write here VA dash is equal to under root of this horizontal square plus vertical square, and similarly VB dash as this square plus this square. So I have written formulas here. Similarly alpha dash, if you see alpha dash, I can write it as tan inverse of this vertical component upon horizontal component. Similarly beta dash is equal to tan inverse of this vertical component upon horizontal component. So I have written these four formulas. Now what we need to find out, this unknown VAT dash, VAN dash, VBN dash and VBT dash. If we find out these four unknowns, then we can find out VA dash, VB dash, alpha dash and beta dash. Now how to find out these four unknowns? Now one very important thing you need to remember, that the velocity change which are going to take place, it will be in the n direction only. Okay, that means no velocity change in t direction. What does it mean? It means this VAN, sorry, it means this VAT dash is equal to VAT. That means this velocity, vertical velocity, will remain the same after impact as well. So VAT should be equal to VAT dash. Similarly VBT should be equal to VBT dash. So I have written here VAT dash is equal to VAT. So VAT is what? VA sine of 30. I have written here, it will be VA sine of 30. VA is given, which is 9 meters per second. So 9 sine of 30 will give me 4.5 meter per second. Similarly, this VBT is equal to VBT dash. So to find VBT dash, what we have, VB sine of 60. Okay, so VB is given 12 sine of 60, which gives me 10.39 meter per second. So in this we got VAT dash and VBT dash. As the velocity are not going to change in t direction, we have calculated VAT dash and VBT dash. Now the task is to find out these two unknowns now, which is VAN dash and VBN dash. Now if you see, this is VAN dash and this is VBN dash, and initial horizontal velocities are VAN and VBN. Now the velocities in this horizontal or n direction are going to change. So what we are going to do here, if you see, uh, we are going to use conservation of momentum equation and coefficient of restitution equation to find out these horizontal velocities that we had done in central direct impact problems, where the balls collide to each other along the line of impact. So we can assume This horizontal velocity, they are along this line of impact, horizontal velocities along the line of impact, and we can treat this problem as a, or this horizontal velocities as a direct central impact problem, like a direct central impact problem, and we will proceed with that. Now we'll use law of conservation of momentum and coefficient of restitution formula to find it out. By law of conservation of momentum, okay, treating right side as a positive and left side as a negative, we have this formula ma van. Okay, we are dealing with the horizontal velocities only now. Now law of conservation of momentum in horizontal direction will be the horizontal momentum. We have to consider the momentum of a ball A in horizontal direction plus momentum of ball B in horizontal direction. So v ma van plus mb vbn is equal to final momentum, that is after impact in horizontal direction, that is ma van. If you see ma van and mb vbn, now their direction, the rightward direction will assume it as a positive and leftward will assume it as negative. Now if you see the mass they have given in the question, that the two balls they are identical, that means mass of ball A is equal to mass of ball B. This mass is equal to this mass. Okay, if you see the mass term is common and they are equal, so I can cancel out this mass term from each term, and van, that is velocity, initial velocity in initial velocity is in n direction. How we can find it out directly? Va cos of 30 will give me the initial velocity in n direction, so van will be equal to va is 9 cos of 30, which is 7.79, and that is n direction velocity of ball B is 12 cos of 60, which is 6 meter per second. So we got this initial velocity in n direction of both the ball van and vbn. So just put the values in this equation, treating this as a positive and left side as a negative. If you see ball A initially is moving towards right, so I can write here 7.79, which is van. Now vbn is towards left, so minus vbn is 6, right, is equal to, we don't know van, but its direction, if you see, it's towards left, so I can write here minus van dash, and here vbn, if you see, it is towards right, so it's plus vbn dash. Now this gives me vbn dash minus van dash is equal to 1.79. Let's say this as a equation number 1. Now let's apply a coefficient of restitution formula. If you see, E is equal to, we have this formula, common formula, E for n direction only, for n direction only, E is equal to vbn dash minus van dash, that is the velocity of ball B, okay, after impact in n direction, velocity of ball A after impact in n direction, that is final relative velocity in n direction upon initial relative velocity in n direction. So we'll get vbn dash minus van dash upon van minus vbn. This is the basic equation of coefficient of restitution we have. Now what we are going to do here, we are treating right side as a positive, or towards right as a positive and towards left as a negative. So if you see final velocity of ball B, it's going towards right, which is unknown, so we'll treating it as a positive only, vbn dash. Final velocity of ball is going towards left, so we have put minus van, minus minus becomes plus here, upon initial velocity of ball A is towards right, and which is 7.79, and final velocity of ball B, sorry, initial velocity of ball B is towards left, that means I have to put minus 6 here, minus, that means B velocity minus 6 here, so minus minus become plus. So if you deal with this equation, E is given to us, which is 0.9, Okay, so if you put value of E and simplify this equation, you will get VA n dash plus VB n dash is equal to 12.41. This is, let's say this as a equation number 2. We have this as a equation number 1, this as a equation number 2. Two equations, two unknown, solve them simultaneously. You will get VA n dash is equal to 5.31 meter per second and VB n dash is equal to 7.1 meter per second after solving the equation. Now we already got this VAT dash, which is 4.5 meter per second, and VBT dash as 10.39 meter per second. Now let's put in this formula, that is VA dash is equal to under root of this. Now we got VA n dash, VAT dash. Just put the values, okay, and we'll get the value of VAT dash as 6.69. Similarly, put the these values we have seen this formula. Put these values, we have calculated all the values. Put this in this equation, we'll get VBT dash, and the angles as well. Alpha dash is equal to tan inverse of this. So just put the values of VAT dash and VAN dash, and here also put the value. You will get this alpha as 40.27 and beta dash as 55.67. So in such a problems, oblique impact problem, you just have to remember that no velocity going to change takes place in t direction, which is perpendicular to the line of impact, and change in velocity only in n direction. Okay, so t direction velocity will remain same. This velocity is equal to this, and this velocity is equal to this vertical, and only change which are going to take place in n direction, which can be calculated by law of conservation of momentum and CR formulas. So this is end of our problem, and these are the solution. Thank you.